And so, for example, for Metasploit, I think that would be the natural option to get feedback from real execution of the model. And then we have the planners. So we have experimented with a lot of different planners, and these are the ones that we have selected. And one is called Fast Forward by a guy, Joel Kaufman. So this is a guy from a university that has been working on this. And he, with this Fast Forward and Metric FS, which is the one that he built after, where the actions can also have numerical effects. We have won like several competitions. And it's interesting to see that this planner is still used as a baseline in so that was one planning step, and the execution getting the two agents. So to continue with the talk, what we wanted to see is how really this scales. What happens is we start using this technique in networks with more machines and different numbers of exploits available, etc. So to do our performance evaluation, we basically use 4 metrics, which are the number of machines, the number of pivoting steps, the number of PDDL actions, which are basically related to the number of exploits, and the number of predicates that we put in the goal. Like if the goal is going to be to take control of one machine or simultaneously 100 machines. And so in those metrics, we were able to go up to 300 machines in the network, 20 pivoting steps, and 1,800 actions, and 100 predicates in the goal. So that's we're quite satisfied with the results. And so to do this evaluation, we have built a network which looks like this. So you have the attacker, which attacks through the internet with a gateway, and lots of subnetworks with their switches and routers. And actually, we didn't build like, I don't know, 300 networks, etc. And to do this, we use a network simulator that we have developed, and which we have developed specifically for this pentesting tool. So it simulates at the system call level. So for an agent based on proxy code, which is the model of the impact agent, which executes system calls remotely, it's completely transferred. So we have this simulator, which is realistic from our attacker's point of view, and we can simulate up to thousands of machines on one PC. So after trying this on the real network, we do this performance evaluation. We switch to the simulated network, and here we have the curves with an increasing number of machines. So it goes up to 300, and on the left you have the memory usage. So it takes up to 2 gigabytes of memory. And on the right, you have the running time in seconds. So the planning time goes up to about 15 seconds. And so one interesting thing about this is that it's clearly not linear, but we didn't reach like actually, I don't know the exact complexity of this. I don't know if it's polynomial or exponential, but the important thing for us was that it actually stays quite reasonable with medium-sized scenarios when we can use it. And this was a really interesting result, which, sorry, I didn't mention that you have here the 2 planners that I've mentioned. Here in the app you have a metric FS, and in the bottom you have a FG plan. So FGPlan performs better than metric effort, also in the previous one and in this case also. But what really surprised us is that the memory consumption doesn't augment with the number of pivoting steps. So it doesn't matter if the target machine that you want to compromise is at 1 step or 20. For the planner, in terms of memory, basically the same thing. And in terms of running time, it doesn't go up too much. So this really works well when you need to make plans with lots of pivoting. And here we have increased the number of actions. So this is the number of PDDR actions. It's not actually the number of exploits, but the exploits counted with multiplicity. So we went up to 1,800, and it also goes up by in a controlled way. And in all those cases, FGPlan was outperforming metric effort. So until now, it was like, okay, it's really clear that it's better to use FGPlan. But when we start adding lots of simultaneous goals, we also had a surprise that metric effort handled them very well, and FGPlan started using more memory and time. So this is the things that you really have to do it in